continuity. For example, let me take an example where you have a a function which is a real valid functions. We only discuss the real valid functions in our chapters, entire CBSE curriculum. So if there's a real valid function, and if I am going to plot that in XY plane, so what happens to that is there are multiple ways a graph can occur, right? So maybe a graph can be like this. I'll give you different types of graphs. So maybe a sinusoidal curve. How sinusoidal curves is? That is, it may be a sine. The function may be f of x is equal to sine x. And what about cos x? If f of x is cos x, how the function will be? You know that, right? So it will start from 1. If it is 1 and this is minus 1, it will go to 0. That's how it is, right? And yeah, what if it is tangent curve? So if this is x-axis, this is y-axis, tangent curve is at 0 at pi by 2. You know what happens to tangent curve? It goes to infinity, right? So again, it will start from 0 to infinity, 0 to minus infinity. So what is the difference between this sine x, cos x? I know there's a difference between these two, but they look similar, right? So this is a curve which I can draw without lifting my pen or pencil, whichever you're using to draw the curve, right? Whereas tangent curve cannot be drawn like that, because this curve, when we are moving towards 90, or odd multiples of 90 or negative multiples of 90, there's negative multiples of 90, this goes to infinity, because we know the values of tangent. Let me uh, remind you the values of sine, cos, tan for standard values, right? So that is sine 0, 30, 45, 60, and 90. What is sine 0? 0. Sine 90 is 1. And it keeps repeating. This is 1 by 2. This is 1 by root 2. This is root 3 by 2. Right? Yes. So now, coming to cos, it will be starting from cos 0 is 1. Cos 90 is 0. And this is root 3 by 2. This is 1 by root 2. This is 1 by 2. Tangent is sine by cos. This is 0. This is 1 by root 3. This is 1 root 3. And tan 90 is infinity. And where will I get this infinity? Wherever I get the odd multiples of 90. At even multiples of 90, it will come to 0. That's why 0 and 180 and 360, everywhere it will be at 0. But when it comes to odd multiples, that is pi by 2, 1 pi by 2, 3 pi by 2, 5 pi by 2, the value is not defined. It goes to infinity. So that is the reason I won't be able to draw this curve continuously. I may have to lift my pen from this place to this place, right? So I have to draw this curve and lift my pen, and in a very common, in a very simple way, if I have to explain discontinuity or continuity, a function which whose curve can be drawn without lifting a pen throughout its range, throughout its domain, is called continuous curve. Like sin x is a continuous curve. Okay, so throughout the real numbers, it will be continuous, whereas cos x is a continuous curve, whereas tan x or tan theta is a discontinuous curve. Not in everywhere it is discontinuous, only at the odd multiples of pi by 2, right? So there are many such functions in our day-to-day life, or in our even syllabus, which are actually discontinuous at many places, and there are many other functions, rest of the functions, which are continuous throughout the range. So that is what we are going to discuss all about in this chapter. So let's see. Introduction, it says a function's ability to maintain its graphical form as a continuous wave is known as a continuity. Okay, so it is used in engineering. See what I said, it is used in engineering to make sure that a system functions smoothly and doesn't undergo unexpected changes. For example, if I want to plot a graph of a real life situation, and if I'm very sure that it will never take unexpected changes suddenly, then I can use it in reality, right? For example, if it is continuously going to be having an infinite value which cannot be defined, I won't be able to understand its nature and behavior in the real life situation. That is why it is very important to understand whether whether the graph I'm plotting is going to be a continuous curve or discontinuous curve. So we will be avoiding discontinuous functions in our real type situations. Okay. And what is differentiability? A function is said to be differentiable. What is exactly differentiation? I will discuss in detail. Right now, differentiation is nothing but finding the rate of change of a quantity. Rate of change of a quantity with respect to another quantity. Generally, we express it by dy by dx. That is rate of change of y with respect to x in an xy plane. Okay. So where do we use this? Where do we use this is it is used as a in a physics, for example, in physics we use it as a rate of change of velocity of an object with respect to time. So what do you mean by rate of change of velocity with respect to time? That is dv by dt, which is actually acceleration, right? So rate of change of distance with respect to time can become velocity or a speed. It depends upon are we talking about a vector or a scalar, right? So all these applications are connected to differentiation. Okay, and then comes antiderivatives or integrals. Once you understand the differentiation, we can talk about uh, integrals as well. Okay, so let me now quickly get into the first part of this class, that is continuity. Okay, shall we start? Shall we get into this? This is the basic crux of the chapter. We are going to discuss why we are learning differentiability and continuity in this class, or even in the 12th standard as a whole. This is the reason. Okay, so if you are getting into any technical courses, maybe a Python or maybe another language you want to learn, or maybe data science, wherever you want to interpret the data, you have to plot a curve, or in case of weather forecasting, any kind of scientific applications, you will never be able to omit this topic. So it's very important to understand differentiation and integration as well as continuity and differentiability.